Welcome everyone. Welcome to all my friends and students. Hope you are doing well by His grace. Today we will start the topic electrochemical cells or galvanic cells, also known as voltaic cell. So what is electrochemical cell? It is a device in which redox reactions are used. For what? Used to convert chemical energy to electrical energy. Clear? The device in which redox reactions are used to convert chemical energy to electrical energy. And the most famous example is that of Daniel cell, and that we will discuss here. So in the Daniel cell, we have two half cells. These are known as half cells. That means the oxidation and the reduction reactions are occurring in the separate container. Okay? And this container in which the oxidation and reduction reactions are occurring are known as half cells. In the oxidation half cell, in the left side, in the Daniel cell, we have zinc rod dipped in the 1 molar zinc sulfate solution. In the right side, copper rod is dipped in the 1 molar copper sulfate solution. These two rods are known as electrodes. Zinc electrode and copper electrode. And these two are connected with the help of insulating wires, key and ammeter. They are also joined with the help of salt bridge. Salt bridge is inverted U-tube which contain inert electrolytes such as KCl, KNO3 in the saturated solution form, and which are mixed in a jelly-like substance, mainly in agar-agar jelly or gelatin. So in the salt bridge, we have the saturated solution of inert electrolytes such as KCl, KNO3, etc. prepared in agar-agar jelly or gelatin. Clear? And when the two half cells are connected with the connecting wires and we insert the key, then we have the following observations. What are the observations? First observation is that zinc rod gradually loses its weight. इसका weight कम हो रहा है zinc rod का. What the next thing? The concentration of zinc ion in this half cell increases. Third point, the amount or the weight of the copper rod increases. And the fourth point, the concentration of copper ions decreases. Now let's see how it happens. So during these observations, what happens? Zinc rod is oxidized to zinc ion. Zinc is oxidized to zinc ion with the loss of 2 electrons. and thus the weight of zinc electrode decreases and the concentration of zinc ion increases. The electrons released during this process move towards the copper electrode with the help of external wire, which are accepted by the copper electrodes. And while going to this cell, this half cell, the copper ions present in the copper sulfate solution gain the electrons, and the copper ions are reduced to form copper. So in this half cell, copper ions gain 2 electrons to form copper, and this copper deposit over the copper electrode, and hence the weight of copper electrode increases. So during this half cells reactions, electrons move from the external wire from zinc rod toward the copper rod, and hence zinc is the negative terminal, and here copper electrode acts as a positive terminal. Clear? So the zinc electrode, where we have loss of electrons or oxidation occurs, that zinc electrode is called anode, where we have oxidation. The copper electrode, where copper ions gain electrons or the process of reduction occurs, that copper electrode is called cathode. So in case of electrochemical cell, anode is the negative terminal and cathode is the positive terminal, and electrons flow from zinc anode towards the copper cathode, and current flows in the opposite direction, which can be detected with the help of ammeter. Clear? So that's the working of electrochemical cell. Now, with the passage of time, the amount of zinc ions in the oxidation half cell increases because zinc is oxidized to form zinc ion. And in this half cell, the amount of copper ion decreases as it is reduced to copper. But as we compare, in this case, the amount of sulfate ion or negative charge is more as compared to the copper ion or the positive charge. So in this case, the positive charge increases in this half cell, and in this half cell, negative charge increases. So with the increase in the positive charge in this half cell, subsequently the flow of electron decreases, and as the electrons move in this half cell, here the negative charge increases because of more concentration of sulfate ion as compared to copper ion. This sulfate ion will obstruct the incoming electrons because of same charge, negative charge, and thus the cell will stop working. And that's why we have salt bridge here. So salt bridge is a inverted U-tube which contain inert electrolyte like KCl, KNO3, etc. in the agar-agar jelly or gelatin. So these electrolytes can dissociate to form cations and anions, and the cations will move toward that half cell where we have more negative charge. As we have in this half cell, the amount of sulfate ion increases. So to balance the charge, cation will move toward this half cell, and the anion will move toward this half cell, toward the oxidation half cell, to balance the charges so that cell will not stop working. So that's the function of salt bridge here. So what are the functions? First of all, it connects the circuit by connecting the two half cells. It connects the circuit by connecting the two half cells. Second, it maintains the electrical neutrality of the two half cells. Clear? So that's the functions of salt bridge, and that's about the electrochemical cell, which convert chemical energy to electrical energy. So till now we have discussed about the arrangement, about the observations, about the working of an electrochemical cell, Daniell cell. And then we have discussed about the salt bridge and the functions of salt bridge. Now, it is observed that the cell potential, that is the EMF of the electrochemical cell of the Daniell cell, is 1.1 volt. That is the potential developed in case of a Daniell cell. Clear? Now we will see here that what is the effect of external opposing potential on electrochemical cell, on this Daniell cell. मतलब अगर हम बाहर से पोटेंशियल अप्लाई कर रहे हैं Daniell सेल पे, तो उस पोटेंशियल का सेल पे क्या असर पड़ेगा? हाउ विल द सेल फंक्शंस नाउ, वो देखते हैं. ठीक है, मतलब एक बार हम देखेंगे कि अगर वो सेल पोटेंशियल जब अप्लाई कर रहे हैं, एक्सटर्नल पोटेंशियल, अगर वो लेस देन 1.1 वोल्ट हो तो सेल कैसे फंक्शन करेगा? एक बार 1.1 वोल्ट ले लेंगे और एक बार मोर देन 1.1 वोल्ट लेंगे, तो तीनों केस में सेल किस तरह बिहेव कर रहा है ना, वो देखते हैं अभी विद द हेल्प ऑफ एक्सटर्नल अपोजिंग पोटेंशियल. ठीक है, फर्स्ट केस लेते हैं. फर्स्ट केस हमने क्या लिया कि जो हमारा एक्सटर्नल पोटेंशियल है जो अप्लाई कर रहे हैं हम, वो लेस देन 1.1 वोल्ट है. तो क्या पाया गया? अब भी ये सेल वैसे ही बिहेव कर रहा है जैसे पहले कर रहा था. मतलब अब भी इलेक्ट्रॉन्स फ्लो करेंगे फ्रॉम जिंक टू कॉपर, करंट फ्लो करेगा फ्रॉम कॉपर टू जिंक. अब भी वही सेम होगा. जिंक विल डिसॉल्व इन द सॉल्यूशन एंड कॉपर विल डिपॉजिट ओवर द कॉपर इलेक्ट्रोड. वही सेम होगा भी. कब? अगर सेल पोटेंशियल जब अप्लाई कर रहे हैं वो लेस देन 1.1 वोल्ट है तो. ठीक है, अब आते हैं सेकंड केस में. इस केस में क्या है? जो हम एक्सटर्नल पोटेंशियल अप्लाई कर रहे हैं वो इक्वल टू 1.1 वोल्ट है. तो इस केस में क्या होगा? व्हाट विल हैपन हियर? नाउ देयर इज नो फ्लो ऑफ इलेक्ट्रॉन्स एंड current here or current here. That means the cell will stop working. There is no chemical reaction. When the external opposing potential is equal to cell potential of the cell, which is 1.1 volt. ठीक है, थर्ड केस में आते हैं। नाउ व्हेन द एक्सटर्नल सेल पोटेंशियल इज मोर देन 1.1 वोल्ट, अब क्या होगा? नाउ द इलेक्ट्रॉन्स विल फ्लो फ्रॉम कॉपर टू जिंक, उल्टा हो गया, करंट विल फ्लो फ्रॉम जिंक टू copper. That means now it will behave as a electrolytic cell and it convert electrical energy into chemical energy, ठीक है, for a non-spontaneous process. तो इस केस में जिंक डिपॉजिट करेगा ओवर द जिंक इलेक्ट्रोड and copper will dissolve, यहां उल्टा हो रहा है, ठीक है। So in this case when the external potential is more than 1.1 volt, then the electrochemical cell, then this Daniel cell will behave as a electrolytic cell, ठीक है। That means here the external potential जो हम अप्लाई कर रहे हैं, the external electrical energy is used to carry out non-spontaneous chemical reaction, ठीक है। So that's about the functioning of the cell when external opposing potential is applied for a Daniel cell. तीन केस किया हमने। when the cell potential is less than 1.1 volt, तब क्या हो रहा है? when the cell potential is equal to 1.1 volt, तब क्या हुआ? और लास्ट केस में when the cell potential is more than 1.1 volt, तब क्या हुआ? जब less than था, less than 1.1 volt, it will behave same, it will behave like a electrochemical cell. when the cell potential is equal to 1.1 volt, cell will stop working. and when the cell potential जब अप्लाई कर रहे हैं एक्सटर्नल से, it is more than 1.1 volt, then the cell will behave like electrolytic cell, ठीक है। okay, now come to the last topic of today's lecture, that is representation of a cell, that how can you represent a electrochemical cell with the help of oxidation and reduction reactions occurring in a cell. So we should follow some conventions here, some steps here. First convention is that we should write anode on the left side and cathode on the right side. That's the first point. Second, for anode, first write the metal and then the electrolyte in the form of cation. Clear? For anode, first of all write the metallic form and then the electrolyte cation. For cathode, उल्टा कर देंगे, opposite. First write the electrolyte, that is the cation, and then write the metal. Okay? And the metal and the electrolyte, that is cation, are separated either by semicolon or by a vertical line. Example लेते हैं. So for anode, हम पहले क्या लिखते हैं? पहले metal, फिर उसका electrolyte. Suppose we have a Daniel cell. Left में क्या है? जिंक रॉड डिप्ड इन द जिंक सल्फेट सॉल्यूशन, तो वो हमारा क्या है? एनोड है। इसमें पहले क्या लिखेंगे? उसका मेटेलिक फॉर्म, मतलब जिंक, फिर सेमीकोलन, फिर उसका इलेक्ट्रोलाइट मतलब जिंक आयन, ऐसे शो कर सकते हैं। एक और तरीका है बाय वर्टिकल लाइन, मतलब जिंक वर्टिकल लाइन और फिर जिंक आयन, ठीक है। साथ में उसका कंसेंट्रेशन भी शो कर सकते हैं, एक्वस कर सकते हैं, या फिर इट्स कंसेंट्रेशन, सपोज वी हैव 1 मोलर हियर, यू कैन शो लाइक दिस द एनोड ऑफ ए इलेक्ट्रोकेमिकल सेल। अब आते हैं कैथोड में। फॉर कैथोड फर्स्ट ऑफ ऑल राइट द इलेक्ट्रोलाइट एंड देन द मेटल। द इलेक्ट्रोलाइट इज कॉपर आयन in 1 molar form, then vertical line and then copper। आप यहां पे सेमी कोलोन भी यूज कर सकते हो या फिर वर्टिकल लाइन यूज कर सकते हो, ठीक है। दैट्स हाउ यू कैन शो एनोड एंड कैथोड। क्लियर। अब आते हैं थर्ड पॉइंट में। द साल्ट ब्रिज विच सेपरेट द 2 हाफ सेल is indicated by 2 vertical lines। तो फाइनली हम शो कैसे कर देंगे? लेफ्ट में क्या था? एनोड। कौन सा है? जिंक। जिंक, फिर वर्टिकल लाइन किस में जा रहा है? ये जिंक आयन में। इट्स कंसेंट्रेशन इज 1 मोलर फॉर अ डेनियल सेल। देन 2 vertical lines, then copper ion, its concentration, then vertical line and then copper। So that's how you can show the cell representation। It's the example for a Daniell cell। Clear? तो आप घर पे और ट्राई करना डिफरेंट सेल्स के सेल रिप्रेजेंटेशन, ठीक है। So that's how today we cover electrochemical cell, its working and functions of salt bridge। Then we take the example that what will happen when we apply some external potential on a Daniell cell, on an electrochemical cell, then how will it work, how it will functions। फिर हमने वो कवर किया था। लास्ट में क्या शो कर दिया? द रिप्रेजेंटेशन ऑफ ए सेल। हम सेल कैसे रिप्रेजेंट करते हैं। So see you tomorrow for the next lecture। तब तक के लिए नमस्ते, थैंक यू।